exposure to the water crisis started during my JC time. We flew to Siem Reap, Cambodia. I think at that point in time, I realized how scarce water is at that region. So I went into the water industry, hoping that I could make an impact.
There's no substitute for water. Over 90% of climate disasters are water-related. So deep tech is offering us technologies to help us alleviate some of those challenges.
There is nothing that gives you more happiness when you have built a technology that people are using it. And you not only enable them with clean power, but at the same time mitigate global warming.
There have been efforts to accelerate the development of climate solutions in Singapore. We see deep tech as the next frontier to help us transform industries and work towards a net zero future. Sustainability, especially decarbonization, is becoming increasingly top of mind for many industry stakeholders, governments, corporates, even individuals.
Can you see these houses on this island? These were powered by diesel in the past, but not anymore.
This man is on a mission to power the world in a clean and green way, starting with the island of Pulau Ubin.
Studies have revealed that if you start reducing the diesel consumption, the neighboring ecosystem flourishes.
Pulau Ubin is unable to draw power from Singapore's main power grid. Instead, it runs on diesel to generate electricity.
When you burn diesel, it creates multiple issues like pollution, and it is expensive. So having a renewable energy will provide a stable power in the longer run to Ubin residents.
In 2022, the Singapore government appointed energy company EDP Renewables to install a solar green roof. But storing energy was a problem. This is where Dr. Avishek Kumar's technology comes in.
Sun is not available all the time, and our need runs 24/7. And if you rely on energy source that is not consistent, it creates multiple problems. And so batteries are the key critical components.
In May 2018, Dr. Avishek Kumar launched VFlow Tech, a clean energy startup that manufactures vanadium redox flow batteries. Vanadium is a metal used to make steel alloys in space vehicles or even nuclear reactors. It also can be used in rechargeable or redox flow battery technology.
The key advantage of vanadium redox flow battery technology, it has more than 25 years of lifetime. There is no degradation. We are using 90% liquid. So even if there is a fire, it cannot be propagated because liquid is inflammable.
Here's how the battery works. They are housed in these large containers. Inside are 2 tanks filled with liquid electrolytes containing vanadium. Both are connected to a cell stack, the heart of the battery, made up of a positive electrode, negative electrode, and membrane. When power flows through it, an electrochemical reaction happens, allowing users to store or dispense energy. Over in Pulau Ubin, VFlow Tech has installed one of these batteries. It can dissipate uninterrupted energy for up to 16 hours. This means less pollution for the residents.
Our objective is to completely remove the diesel genset. We have been able to reduce about 100,000 liters of diesel consumption annually, about 268,000 kilograms of carbon dioxide offset on a year basis.
Deep tech startups are turning to Earth's natural resources for alternative power. Beyond the sun, water plays a crucial role in industries like textile manufacturing, where it's used for processes like dyeing and washing. This factory draws 3,500 cubic meters of water daily from a nearby river, but it requires chemical treatment to meet industry standards.
In the past few years, with climate change, the weather patterns are very erratic. So this causes the river water quality to fluctuate. During dry seasons, the quality of the water worsens quite a lot. So their textile company is exploring more sustainable treatment processes, and that's where they actually reach out to us.
So it's like, I think some parts is also like quite wide, but some parts is quite not clean very efficiently, I think.
In 2022, Tai Ki co-founded Atera Water in Singapore. It manufactures a membrane-based water filtration system used for a variety of applications. This project in Johor is their first commercial deployment.
Their current chemical process does incur a lot of operational costs because of the chemicals purchased and its consumption. We propose to use TerraStream, which is a submerged membrane system. In a simplified manner, you could see membranes as a sponge. So like a sponge, our membranes also have a lot of holes that allow the water to pass through, but just that the holes are small enough to only allow water molecules to pass through, but is able to block out the dirt, the contaminants. We don't use any chemicals, neither do we produce any sludge, and the output of the water is also able to meet their water quality standards.
What makes Atera Water's technology effective and environmentally friendly? Filtration membranes for water treatment are typically made of polyvanillidine fluoride, or PVDF, a rather expensive material. Atera instead uses a commodity polymer, polypropylene, commonly found in everyday plastic products to lower the material cost. They also added nanofillers to strengthen the membrane, increasing its lifespan from months to up to 4 years. This results in companies saving up to 50% in costs, and more importantly, it benefits the environment.
PVDF use a lot of solvents to dissolve the material, and eventually they also create a lot of wastewater that is contaminated with these solvents. We are manufacturing them using a solvent-free and water-free process, generates no toxic chemicals or no toxic wastewater.
So how does Atera's technology ensure a higher quality of clean water?
Our membranes has slit pores, and what it does is allow water molecules to pass through without large solid brown particles to get stuck. This is to minimize the frequency of choking. The conventional membranes are not able to take a very high threshold of solids.
Startups like vFlowtech and Atera Water have potential, but the road ahead is filled with challenges.
Deep tech startups typically face a few challenges. Many of them require heavy capital outlay, especially on the onset, and long commercial pathways. Having the right type of investors and the right type of venture builders to support startup is important. That's where Enterprise Singapore looks towards attracting and working with global venture capitalists that specialize in these climate tech areas.
One such venture capitalist is Paul Santos, who believes Singapore has the right framework to take deep tech climate innovations forward.
Singapore is a great place to develop deep tech startups. There's talent here that people don't expect. Other ecosystems might have the talent, but if the customers aren't there, it's very difficult to grow your business. The third is investors. Singapore is the region's foremost financial hub, and there are willing investors here looking to back startups that are going to create the next breakthrough.
There have been efforts to accelerate the development of climate solutions. We see innovation as a key enabler for climate technologies. Sustainability, especially decarbonization, is becoming increasingly top of mind for many industry stakeholders, governments, corporates, even individuals. There are also sectors like shipping, aviation, transportation, petrochemicals. These are sectors that need really novel solutions to really help them address sector-specific challenges, and there's a demand for such solutions.
In 2018, Dr. Avishek Kumar met solar expert Dr. Arjun Bhattarai, and together they started vFlowtech, a company specializing in redox flow batteries. But they couldn't take their innovation forward.
Enterprise Singapore, as a startup development agency, we work with innovation partners, NTUs, Ecolabs, centers of innovation, to gain access to domain and technical expertise and guidance, as well as local and regional opportunity to test bid their solutions.
This is where Professor Madhavi from Ecolabs stepped in.
VFlowTech technology is definitely a game changer in the battery world. I'd had my questions in mind that, hey, can they scale up? Would this work? Can it compete with the landscape of batteries?
Professor Madhavi Srinivasan researches into novel energy storage solutions and e-waste recycling, and she helms NTU's Energy Research Institute and Ecolabs, helping startups like VFlowTech think long-term.
The purpose of Ecolab is to really support startups and SMEs in the Singapore ecosystem and the global scale. There's a saying that you need an entire village to actually support a child's growth. So similarly, a startup needs all the possible help it can get to make it to success. In the sustainable energy transition landscape, things move very fast. Startup SMEs are working on a particular product and they are so busy doing this that sometimes they need help on, hey, what's happening in the ecosystem around their product. We conduct specific workshops. These workshops can be a mixture of technical, global perspective, business kind of workshops, which tells them what's happening in the field globally.
Ecolabs also provided VFlowTech a testbed for their technology.
This helps them test their product in a real-world scenario. They get the feedback and go back to the university ecosystem to fix the R&D innovation problem. So this sort of a circular kind of multiple jigsaw puzzle coming together to support a VFlowTech is very, very important. A lot of our sustainability energy challenges are really at the intersection of various disciplines. So SME startups look for such multidisciplinary experts, students, researchers who understand the intersection of various disciplines. We train the talent on these next generation technologies so that when they join the company, they can hit the ground running.
But VFlowTech has other issues that require immediate attention.
We are at a point where when our cost of production are quite high. For us, going to a next stage requires multiple enablers to be there. One enabler is financing of the product. Second aspect is the scalability. So how do you scale from a 10 megawatt hour factory to about 100 megawatt hour? This has not been done in the past. So there is uncertainty about that scale up. Anything that goes wrong can put you in a valley of death.
Tech startups require typically a heavy capital outlay, especially at the onset. And I think this is where in our ecosystem, Enterprise Singapore, we try to make sure that we do have the right type of venture capitalists and venture builders to support startups in this space. It's important that these venture capitalists have the expertise in the right areas, in this case climate, and are able to support the companies not just in terms of financing, but also in supporting the growth journey.
Through the support of Enterprise Singapore, VFlowTech was able to get specialized manpower needed to deploy an automated stack assembly line. The company also received funds from several investors, such as Wavemaker Partners, an early-stage venture capital firm.
Over the last 12 years that we've been around, we've seen at least the venture innovation system become more and more vibrant. So there are more willing investors ready to back technology startups that are solving meaningful problems. So we've supported VFlowTech through its journey in a few ways. So the first is we invested in them. You really need capital to be able to move from pilot to production. Second, we've introduced them to potential partners and customers. Third, we've introduced them to some of the experts in our network. So, for example, we've introduced them to one of the premier deep tech investors from Singapore who's joined their board.
For Atera's Tai Ki and co-founder Dr. Adrian Yeo, support from NTU was crucial.
Okay, shall we start the test?
Okay.
Without the university's resources, they would not have been able to develop their innovative membranes.
When we started the company, our main membrane material was co-developed together with NTU under the Material Science and Engineering faculty. So as of now, we actually co-own the patent together.
Okay, so I think it break at this point is about 8
8.2. They have existing resources, existing analytical equipment to help us look at how can we better develop and analyze the properties of our membranes. So do you want to increase the flow rate and see what's the effect?
Maybe we go up to 5 liters per minute.
Okay.
Aterra Water makes water treatment systems for developing countries. In 2023, founder Tai Ki and team designed a membrane system that can effectively clean water with high solid content.
This is a typical membrane bundle. What the air does is to create turbulence within the water so that the fibers don't get too stuck together with the dirt, so that the water flow throughout the membrane is as consistent as possible. The water comes out and collected into a tail below here, and we'll measure the water quality later. Then we'll test what is the difference between solids concentration in the water and in our treated water, and that will measure the performance of the membranes as well.
Aterra Water worked with Enterprise Singapore to launch a pilot project in Johor, the company's first commercial deployment. But support also came in other forms.
Enterprise Singapore also provide a lot of support, such as introducing us to their network within the region. If we were to go to Philippines, if we were to go to Indonesia or Vietnam, they would introduce us to some of the partners they have in the region. So I think in terms of all this network, it creates a lot of shortcuts for us as compared to us finding our own partners that we may or may not know who to trust in those new regions.
Aterra Water is preparing to tackle water challenges in Vietnam. It will be supported by Imagine H2O, a non-profit venture builder.
With Aterra, we've been working over the past 6 months on 3 key areas. We're trying to help them connect to customers and investors, but crucially find those early customers to help with their testing and validation as their product development is ongoing. Let's just check in on where the startup support is for Aterra. I know we're looking at Philippines, the event that we're going to work with them on.
I think like their location at our pavilion was great. They managed to break skid down, and so they were able to show all the different stakeholders, how their membrane looks like and how the system works.
The second piece is market advisory. So we want to help startups retire risk faster, test their assumptions, particularly as they look beyond Singapore shores and start finding their first customer in an overseas market. And the third is designing and financing one of their first pilots in Vietnam. In Vietnam, we're going to be exploring this configuration, correct?
Oh yes, so for the Vietnam project, we are actually deploying 40 of these curtains.
There's a lot of risk aversion in the water sector. There's financial constraints that prevent a lot of end users from trialing new technologies. With Aterra, we've been exploring an opportunity to see if we could support their pilot in Vietnam.
So if we do have other clients that we meet that have a similar pain point in Vietnam, we can actually bring them to take a look at the plant, to also use the plant to let them understand how the system is running. Speed around 400.
Yeah, 400 is fine.
What we realized is that because Southeast Asia, we're all very close to each other, the challenges that we see are actually very similar as well.
Like any technopreneur with great ambitions, Dr. Avishek Kumar too dreams of expansion.
Is this the carbon felt, new felt that we have gotten?
In January 2023, VFlow Tech raised $10 million in a Series A round, which helped it launch a 100 megawatt-hour production line in India.
In India, we are building about 1 battery a month. The target is to build 10 batteries a month to 1 battery a day from now to 2026.
They are also looking to expand their presence elsewhere. Global expansion aside, VFlow Tech also has plans to improve productivity in its Singapore facility.
So we have been manually producing stack. Currently, we do about 44 stacks a week. We want to go to 40 stack a day. And our target is that in next 8 to 10 months, we build that first automation line.
They are also piloting their solutions in other areas, like a 1.6 megawatt-hour energy storage system on Jurong Island.
So Jurong Island has a lot of industrial waste where you can generate vanadium. You can get vanadium from petroleum waste or industrial waste. At the same time, they have been storing a lot of chemicals on these larger tanks. So as a concept, we proposed that we can use their tanks and we can power their operations using the renewables that they have and also enable battery to do multiple functionality. If we can do it successfully, we can use the existing infrastructure of Jurong Island to scale our technology from 2 megawatt hour to 200 megawatt hour on Jurong Island without impacting any other additional spaces.
New, deep technologies like these serve two needs: to solve global crises and enhance Singapore's long-term competitiveness.
We see deep tech as the next frontier to help us transform industries. These global shifts have shaped our climate tech landscape and creates immense opportunities for climate tech startups, especially those with novel, disruptive solutions and business models.
There are more than 1 billion people who don't have access to clean and affordable electricity. Having an affordable, low-cost batteries, clubbing with solar, will enable a low-cost energy transition.
I guess as a personal goal, what I do hope is to go back to Cambodia. Probably the people or the villagers there can use our technology to increase their water supply, increase their water accessibility.